Hey guys, welcome to the channel VIBGYOR of Talents. So in today's video, we'll be looking at the part 2 of chemical reactions and equations. It is the first chapter of science of class 10 CBSE. So let's get started. So this was the previous video of VIBGYOR of Talents. It was the part 1 of chemical reactions and equations. So watch this previous video and then continue watching this to get a better understanding of this chapter. Okay, so let's get started. In the previous video, we have looked at the types of chemical reactions. We have just seen the names of each of the types of chemical reactions, and I have said that we'll be looking at each of them deeply very soon. So it's the time now to look at each of the chemical reactions very deeply. If you remember the types of chemical reactions, what are they? Let's see each of them right now. Okay, number 1 comes the combination reaction. So basically, in a combination reaction, two elements or one element and one compound, otherwise we can say it like two compounds combined to give one single product. Like if we add 2 plus 2, we get 4. What do you observe on the left hand side? It is LHS. It is 2 plus 2. But after we have added it, what we have got? Before there were two numbers, but after we have added it, we got a single number. So combination reaction is something similar to this. In here, we have two elements or only one element on the left hand side, but when it comes to the right hand side, it is always one element. It gives one single product. So for your better understanding, let's see some of the examples. We have H2 plus Cl2 on the left hand side, that is one element plus another element turns into 2HCl, the compound. I have said you right, 2 plus 2 turns to 4. So here also H2 plus Cl2 turns to 2HCl. Okay, and then 2CO plus O2 turns to 2CO2. Here one compound plus one element turns to one compound. At last, in the product side, we'll just have one element or one compound at last. We should remember that in combination reaction. How many ever would be on the left hand side? At last, we would get a single product. Then we can say it as a chemical combination reaction. Then NH3 plus HCl, which turns into NH4Cl. Compound plus compound turns into compound. Some of the examples may be blurred. Sorry for the inconvenience caused. Okay, now let's move forward and see what is the second type of reaction. Now we have the decomposition reaction. In here, a single reactant decomposes on the application of heat or light or even electricity to give two or more products. So in decomposition reaction also, we have subtopics or subdivisions in this. Number A. Sounds funny, right? Number A. Okay, let's continue. Decomposition reaction, which requires heat, is known as thermolytic decomposition or thermolysis in short. So this is one of the type of decomposition reaction. One of the example of this thermolysis is the thermal decomposition of HgO. And the second type of decomposition reaction that we have is the decomposition reaction which requires light, which is known as photolytic decomposition or in short photolysis. For example, we have photolytic decomposition of H2O2 over here as an example. Okay, let's jump to the next one. Number 3, we have decomposition reactions which require electricity. Electrolytic decomposition or electrolysis is the third type of decomposition reaction. We have learned about electrolysis of H2O and etc. the previous classes too. So for example, here we have electrolytic decomposition of H2O as an example of the third type of decomposition reaction. So these were the different types of decomposition reactions. Let's jump forward now. The third type of reaction that we have is the displacement reaction. So you may be wondering how to define it. So let's see. We can define displacement reaction as more reactive element displaces a less reactive element from its compound or solution. So this would be something like A weak boy bought some chocolates from a nearby shop, where one strong boy came and snatched the chocolates from that weak boy and ate it himself. Here also the same thing happens. The more reactive element comes and kicks out the less reactive element and takes its place. We will know which element is more reactive and less reactive by looking at the reaction table. We have learned about the reaction table in the previous classes. If you hadn't remembered it, I will give a link in the description. You might open it to look at which elements are more reactive and less reactive by looking at the reaction table. So now let's look at one of the example of the displacement reaction. Once again, sorry for the bad quality of these example, guys. The images were not proper. Okay, so in the example we have Zn plus CuSO4 turns to ZnSO4 plus Cu. That is one of the example. And second example we have Cu plus 2 AgNO3 turns to Cu NO3 taken twice plus 2 Ag. So we can simply write this displacement reaction as AB plus C turns to A plus BC. Remember it this way, it would be more easier. Okay, the fourth type of reaction that we have is the double displacement reaction. We have seen about the displacement reaction before. Now let's look at what is a double displacement reaction. An exchange of ions between the reactants take place to give new products. So this is the exchange between the ions in order to form new products. This is known as double displacement reaction. It's the simplest. For example, here we have Al2SO4 taken thrice plus 3CaOH taken twice turns to 2AlOH taken thrice plus 3CaSO4. So in here you can look at this picture for more information and to remember this very easily. So here A and C are cations, that is positive ions, and B and D are anions, that is negative ions. You can remember it this way. And the next type, that is the fifth type of reaction that we have, is the precipitation reaction. So we can define it as an insoluble compound called precipitate forms when two solutions containing soluble salts are combined. You might be knowing what is a precipitate. It is like the small things which are laid down below at the base of the container when it's left undisturbed for some time. Okay, let's look at one of the example of this precipitation reaction. It is PbNO3 taken twice plus 2Ki turns to 2KNO3 PbI2. So this is one of the example of this precipitation reaction. To know more about the precipitation reaction, I will leave a link in the description. You can browse it to know more about it. Okay, cool. Let's move forward and see what we have next. So number 6, we have a redox reaction. Oxidation and reduction takes place simultaneously. It's known as redox reaction. Combination of two of these words. So you might be wondering, what is this oxidation and reduction? We will know about them right now. So we can define oxidation as substances lose electrons or gain oxygen or loses hydrogen. So we can say oxidation is taking place when something loses electrons, element loses electrons or gains oxygen or loses hydrogen. So we can write reduction as substance gains electrons or loses oxygen or gains hydrogen. So what is this oxidation agent now? A substance that oxidizes another substance and self gets reduced is known as an oxidizing agent. We also have a reducing agent, that is a substance that reduces another substance and self gets oxidized. To get more information and to remember it quite goodly, let's see some of the examples of it. Here we have Fe plus CuSO4 turns to FeSO4 plus Cu. Here Fe turns to Fe plus 2 plus 2Ee. That is the oxidation, and Fe is the reducing agent. And in the second part we have Cu plus 2 plus 2E turns to Cu. This was reduction. So Cu was the oxidizing agent here. You get it right here. Okay. And then the second example that we have is ZNO plus C, which turns to Zn plus CO. So in here, ZNO reduces to Zn, that is reduction, and C oxidizes to CO, which is oxidation. So ZNO is the oxidizing agent and C is the reducing agent. In here for this example. Know more about redox reactions, I will leave a link in the description. You can open it and find out more. Okay, so let's look at the last endothermic and exothermic reactions. Exothermic reaction is the one in which heat is evolved during a reaction. Most of the combination reactions are exothermic. For example, we have Al plus Fe2O3 turns to Al2O3 plus Fe plus heat. So here we can see that heat is being released. So we can say it as exothermic reaction. So as you might be thinking, endothermic would be the opposite of exothermic. That is, heat is required to carry out this reaction. In the previous one it was releasing. In this one it is taking. So for example, we have 6 CO2 plus 6 H2O plus sunlight turns to C6H12O6 plus 6O2. So what is this C6H12O6? It is the glucose indeed. So most of the decomposition reactions are endothermic. To know more about exothermic and endothermic reactions, I will leave the link in the description. You can find it. Now let's know about corrosion. You might be knowing what is corrosion. It is a gradual deterioration of a material, usually a metal, by the action of moisture, air or chemicals in the surrounding environment. So rusting can be written as 4Fe plus 3O2 plus XH2O, that is moisture, which turns to 2Fe2O3 into XH2O, which is rust. Corrosion of copper. Cu plus H2O plus CO2 turns to CuCO3 into CuOH taken twice. Corrosion of silver. Ag plus H2S turns to Ag2S plus H2. To know more about the reaction, I will leave a link in the description. You can find it. Okay, so now let's look at rancidity. Rancidity refers to the oxidation of fats and oils in food that is kept for a long time. It gives foul smell and bad taste to food. Rancid food causes stomach infection on consumption. So how can we prevent this rancidity? Use of airtight containers, packing with nitrogen, refrigeration, addition of antioxidants or preservatives can be used. So that's it guys, we are thorough with this chapter. Thank you for watching this video and please follow us on Discord, Twitter, Instagram and other social media handles. The links are in the description, you can find them. There are many other documents also which you can find to know more about the topics. Please visit the description to see all of them. Thank you once again for watching this video.